Hey folks, how's it going? It's Mr. Murray coming to you with another video. Today's video is going to be covering simplifying square roots. Alright, so in this video what we're going to be doing is just breaking it down for you. How do we take square roots that are maybe not whole numbers and simplify them in a little bit more compact way? This has come up recently because in class we've been talking about the distance formula for finding the length of the side of a quadrilateral, and now what we need to do is we need to go ahead and try to see if there's a little bit more compact way. Now we know that some square roots break down pretty nicely, such as the square root of 4. Well, we know the square root of 4 is equal to 2 and the square root of 9 is equal to 3. But what do we do with numbers like the square root of 8 and the square root of 12? Because no number times itself equals 8, and not a whole number that is, and no whole number times itself equals 12. So by the end of this video, you're going to be able to take 8, and you're going to see why 8 is equal to 2 times the square root of 2, while 12 would be equal to 2 times the square root of 3. It might not make sense where this is coming from now, but again, by the end of this video, you're going to see where I'm coming from. And as with many of my videos, there's going to be problems that I'm going to do, that we'll do together, and then for you to try on your own. Alright, so in order to really be able to make sense of this, we're going to have to take a look at what perfect squares are. So the numbers you see here on the left, 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, and so on, these bolded numbers, these are called perfect squares. And perfect squares are numbers such that their square root is also a whole number. Okay? And we call these numbers rational. All right? On the other hand, a number that is not a perfect square will have what we call an irrational square root. So for example, and I did this on Google, the square root of 2 is equal to 1.41421356237, and you might think that it stops there, but actually it does not. And in fact, there's no really way that we're ever going to be able to make square root a rational number. Its decimal will go on forever, and it will never really have a pattern to it. And if we actually tried to write it as a number divided by another number, that is the ratio of two numbers, it's never going to work. That video might be for another time, but 2, suffice it to say, is not one of these special numbers. So again, some examples of perfect squares: 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. And they actually do go on forever and ever and ever, right? We could do, for example, 625 is a perfect square because when you take its square root, you get 25. 1,000 is a perfect square. Actually, no, 1,000 wouldn't be. 10,000 would be a perfect square because when you take its square root, you get 100, and so on and so on. And perfect squares are really the crux of how we're going to do this problem. And that's because, right, while some numbers like 8 and 12 don't have whole number square roots, numbers that multiply to get those numbers, such as 8 and 12, there's numbers there that do have square roots. Let's take a little bit of a dive into this. So this is going to be really underpinned by this multiplication property of square roots. And what that means is that the square root of a times b is equal to the square root of a times the square root of b. Okay, so verbally, the square root of a product of two numbers multiplied together is equal to the product of square roots. And as an example, we know that 36 is equal to 9 times 4. So then that means that the square root of 36 is equal to the square root of 9 times the square root of 4. Now, we know that 3 times 3 equals 9, so that means that the square root of 9 is equal to 3, and 2 times 2 is equal to 4, so the square root of 4 is equal to 2, and we know that 3 times 2 is equal to 6. As you might have seen if you were taking a look at the previous slide, you would have also seen that the square root of 36 is 6, because 6 times 6 is 36. But one thing that's actually pretty powerful here is that this doesn't just work for perfect squares. It also works for numbers that, like 8 and 12, are not perfect squares. And so what we need to think about is the fact that if two numbers multiply to get another number, then we can take that number's square root and break it down. And if we can find a number, A or B, that is one of these perfect squares, it's going to make a really big difference in simplifying that square root. All right, the process. So to simplify a square root, we need to take the number n under the square root, which is called, also known as the radicand, and we're going to split it into two numbers, a and b. And so a times b is going to have to multiply to get n, because this is going to allow us to use that multiplication property. And it's important that one or the other is a perfect square. Now notice how we say except for 1, and that's because any number times 1 is that number itself. So using 1 is not going to be helpful because it's not going to change anything. Okay, though 1 is a perfect square. So for example, we're looking for numbers like 4, 9, 16, 36, 49, 64, 81, 100, etc. We're looking for one of those numbers to be a factor of that number under the root that we're starting with, okay? And so what we're going to do is we're going to break it down, that square root of n, as the square root of a times the square root of b. And what's good about this is that one of those two numbers, a or b, is going to be a perfect square. So what that means is that you can rewrite the square root because you know that it's a whole number. So you're going to take the square root of that perfect square because it will then become that whole number because it's a perfect square, and you're going to remove the root because you've evaluated that square root. The other one is not going to be a perfect square most likely, so you're going to leave that one as is. Then what you're going to do, step 4, you're going to look to the number that remains under the square root, and you're going to ask yourself, can I repeat this process, step 1, 2, and 3, by with this number that's under the root? And if you can, you continue to repeat it, and if you can't, then you're all set and you leave things as is. Now this is a very complicated process, at least it seems that way at first, and so what we're going to do is we're going to work through a few examples, and hopefully in working through these few examples we're going to get some valuable practice in there, and we're going to see that this is actually something that we can master with enough practice, but pretty solidly once we have that practice. All right, so I'll try this first one for you, okay? So we have the square root of 8. Now we know already from the first slide that we should be expecting to get 2 times the square root of 2. But where does that come from? Well, the first step is we need to split a into two numbers, 8 that is, into two numbers that multiply to 8. And notice two numbers that multiply to 8 are 4 and 2. Now I'm doing it in this order for a reason, and that's because 4 is a perfect square. We know that 2 times itself is 4, so when I take the square root of 4, I know I'm going to get a whole number. Just the same, you saw from my counter example, my non-example of a perfect square, that 2 is not a perfect square, and so therefore when I take its square root, I am not going to get a whole number. But because of that multiplication principle, because 4 times 2 is equal to 8, well, what I know is the square root of 4 times the square root of 2 must be equal to the square root of 8. Again, because 4 times 2 is equal to 8. So that is step 1 and 2. Now what I'm going to do is I'm going to take the square root of that perfect square. So again, 2 times itself is 4. So 4 goes to 2, that square root, and that's just simplifying, rewriting it as the same thing, right? 2 is exactly the same thing as the square root of 4. And I leave the other one as is. I leave that square root of 2. That one comes on down, and that stays the square root of 2. And I see if I can repeat step 1 through 3 using what remains under the root. In this case, there's no perfect square except for 1, and we know that 1 is not going to change what that root looks like. So we are actually done at this point. And so what I have is 2 times the square root of 2 is exactly the same thing as the square root of 8. And so we would consider 2 square root 2, that's how we'd pronounce that, as the most simplified version of the square root of 8. All right, so if that didn't make sense to you, I really do encourage you to go back and take another look through this explanation. But then I'd also like to do another explanation in just a few seconds. So feel free to rewind if needed, and I'm going to move on. All right, so we've also seen the square root of 12, and that one is equal to 2 times the square root of 3. Now, 12 is a little bit more unique because you could break 12 down in a couple ways, right? We know that 12 is equal to 6 times 2. We also know that 12 is equal to 4 times 3. But if you think about it, 4 times 3, though it is the same thing as 6 times 2, is a more favorable breakdown here. And that's because while 4 is a perfect square, 6 is not. So you need to be cognizant of that. You need to be conscious of that and looking out for a number that is a factor. Remember, that means it goes into the number evenly and is also one of those perfect squares. Okay? So again, we get 4 and 3, and so because 4 times 3 is 12, the square root of 4 times the square root of 3 equals the square root of 12. And if you don't believe me, I encourage you to do this on a Google calculator, on a calculator of your own if you have one, to type in the square root of 12 and see what you get, and then to type in the square root of 4 times the square root of 3, and you should see that the values are exactly the same. Now, again, from the previous page, we know that 4, when we take its square root, is equal to 2, so we rewrite this, and 3 we leave as is, and then we see if we can repeat. So 2, we leave that alone, and we ask, well, does 3 have a whole number square root? It does not. Is there a perfect square that will go into 3? And other than 1, there is not. So we are again done, and we leave it as 2 times the square root of 3. All right, so again, I encourage you, if need be, to please go ahead and go back and review anything that might not quite make sense here. And then in a couple seconds, I will move on to another one for us to try. All right, so here's one, and I've left the steps on here, but here's one that I think that we need to try together. So let's try to walk through the steps and think about how we can break this down. So again, the first thing we need to do, and by the way, it's not a guarantee that you even can do this. There's a chance that there are no perfect squares at all that go into this number, and if that's the case, sometimes you need to just leave it as is. Now, of course, because we have these examples, and this whole point of the video is to practice the skill, not likely to happen, but I just want you to be aware, if it was a number like 19, square root of 19, you can't break that one down. Maybe the square root of 20 for that matter. You really can't. Oh, well, 20 you actually could break down. What about 21? So 21, you couldn't break that one down. So again, some you just have to leave as is, and some you can break that down. So let's think about it. So our first step is we really got to break up this 50. Now there's many ways you can do it. So 50, you could view that as 10 times 5. 10 times 5 is 50. So you could say that the square root of 5 and the square root of 10, when you multiply them, is equal to the square root of 50, and that is true. However, can we use this to help us simplify? In this case, we can't, and that's because neither 10 nor 5 is a perfect square. So we do need to kind of leave this alone at the moment, all right? We really, though, we'd love to just have it be that easy, and we'd like to call it a day and kind of wrap things up and say, hey, we figured this one out. We really cannot do that, unfortunately, in this case. So we're going to have to make some alternate arrangements here. All right, no worries. So let's take a look, and how about another combination? What's another combination, two numbers multiplying to 50, but maybe one of them is a perfect square? I'm thinking, what if we did 25 and 2? Now we know that 25 times 2 is equal to 50, and so therefore the square root of 25 times the square root of 2, because of that multiplication property of square roots, must be equal. 25 times 2. Those square roots must be equal to the square root of 50. But now notice how the square root of 25, that is 5, because 5 times itself is 25. And the square root of 2, we are just going to leave that as is. That is the square root of 2. Okay, so 5 times the square root of 2. Now we go back to the square root of 2 and we ask ourselves, can I break down the square root of 2 any further? And the answer is that I cannot, because there are no perfect squares other than one that go into the square root of 2. So we're actually all set, and 5 square root of 2 is what we are looking for right here. Okay, so again, I encourage you to please go back and rewind if needed, and then I will go ahead and move on to another one for us to try to do together. All right, another we try. Okay, so we have 125. So again, we have the process. The first step we need to take is we need to find a perfect square that goes into 125. All right, now what perfect square do you think that could be? So one that jumps out to me right away is 25. I noticed that 25 times 5 will give me 125. Okay, and so for that reason, the square root of 25 times the square root of 5 is equal to the square root of 125. 25 comes down as 5. Square root of 5 comes in as the square root of 5. And I am done, because the square root of 5, there are no perfect squares, again, other than one, but that will leave it the same, that go into 5. All right. So in a moment, we are going to go ahead and go into some ones for you to try. Before we do that, really, really important, if you got any lingering things that you might want to take another look at, I really do encourage you to pause the video, rewind if needed, kind of investigate those areas where you might still be struggling. All right, and then in a couple seconds, we are going to go ahead and move on into some ones where you can try and see if you're kind of getting where we're coming from here. All right, so what I thought I would do is I thought that I would go ahead and give you 4 ones for you to try. So here we have the square root of 48, the square root of 200, the square root of 320, and the square root of 405. And so what I'd like you to do is I'd like you to try to simplify each of these completely. So your final answer, okay, should not include any square roots unless that square root can no longer be simplified. So for example, if you have the square root of 12 in your answer, you got to break that down further, okay? Because 12 we know is equal to 2 square root of 3. So what I want you to do, try your best to break this down as much as possible, simplify completely, okay? So pause the video, try to do that, okay? Then when you're ready, unpause, and I'll show you what I got. Okay, so what we're going to do is we're going to take a look at this, and look, in this case, there's actually a couple ways you could go about solving this. And so what I like to do is I like to show you a couple different ways for how to do each one. And what we're going to see is that you're going to get to the same answer either way. So 48, we might start by doing 4 and 12, and that's perfectly okay. Okay, so because 4 times 12 is equal to 48, we're going to break down 48 as the square root of 4 times the square root of 12. And the square root of 4 is 2. And then we're going to take 12 and we're going to leave it as is. And now what I was getting at is that we got to ask ourselves, okay, can I break down 12 any further? Is 12 also breakable? And we know that it is, because we've seen that from a previous page. So what we know is that we now need to go and we need to split up 12 again. So 12 is equal to 4 times 3. So what I'm going to do is I'm going to open a parenthesis, and I'm going to re-break this, right? So 12, because the square root of 12, because 12 is 4 times 3, the square root of 12 is equal to the square root of 4 times the square root of 3. The 4 becomes a 2. The root 3 becomes a root 3. And now the root 3 there's no perfect squares, again, except perhaps 1, that are going to go into 3. So that is a sign that we are actually done. Now, what do we do with the 2's? Well, the numbers outside of the root can be multiplied as usual. So I'll take the 2 times 2, I'll multiply by 4, and I'll end up with 4 times the square root of 3. Now, the reason that we needed to take multiple steps is because there was actually a bigger perfect square that we could have chosen. So if you didn't realize that 4 times 12, maybe another combination you could have seen is that 16 times 3 is also 48. So observe how we've actually could find a bigger perfect square that goes into 48. That is 16. So if you had written it as the square root of 16 times the square root of 3, the square root of 16 is 4, the square root of 3 is 3. So you can see you actually get the exact same answer, but in one less step. So what I'm getting at here is you always want to see if you can find a bigger perfect square. If you don't find the biggest one, that's okay. But what that means is that it's just going to take you an additional step to get to where you need to be. And that's fine, as long as you get to the ultimately most simplified version in the end. Okay, we could see a similar thing with 200. So there's two ways you could have broken down 200. Some people might see it as 102. Others might see it as maybe 50 and 4. If you see it as 102, when you break it as the square root of 100 and the square root of 2, you get 10 times the square root of 2, and you're done at that point because 2 cannot be broken down further. It's okay though if you see it as 50 and 4, because this would be 2 times the square root of 50. But the thing is, you can't leave it like that, because then again you got to go through the steps and you got to check and see, well, wait a minute, can we break down 50? And 50 can be broken down as 25 and 2. So when you do those square roots, you get 2. The square root of 25 is 5, and then you get 2. And then again, you take the numbers outside of the root, you multiply them, so that is the 2 and the 5, and that gives you 10 times the square root of 2. Again, you can see it's the exact same answer, but it's not simplified until that number inside the root cannot be broken down any further. Okay? All right, so what I'm going to do, I'm going to go ahead and we're going to take a look at the last couple. And this one, I remember now, I wrote as a couple pieces, so we're going to bring those down. Now, 320 turns out, again, multiple ways of doing it. The fastest way is going to come by doing 64 and 5. Now, one strategy you could consider to help you save time is if you have access to the perfect squares, start trying to divide multiple ones. So if you get a hit right away, maybe try to do a couple of bigger perfect squares, and as you do this enough, you'll start to build some intuition. So for example, if 25 goes in there, right, then that means the last two digits of the number are going to have to be a multiple of 25, right? So like 125 we looked at, right? 50 is a multiple of 25. 175, those last two digits, 75, right? 25 goes in there evenly. So you just want to see, and again, if you don't get the biggest perfect square right away, that's fine, but you just got to keep working at it, okay? And that could actually be okay because it's not obvious that 32 is 64 times 5. You might have also seen 320, 320 is 64 times 5. You might have seen it as 16, okay, and 20. Yeah, okay. You might have seen it as, there's a couple ways you could see it. But again, 64 being the biggest one is going to give you the quickest breakdown, and that's going to be 8 square root of 5. Okay, if you did the 16, you'd have to break down the 20 as 5 and 4. So when you did the breakdown, right, there's your square root of 5. The 16 goes to a 4. The 4 goes in as a 2. right? So that when you multiply the numbers outside of the root, you still end up with 8 square root 5. So again, I'm open to being flexible with respect to how you get there. However, that being said, you ultimately do need to get to the simplest form. Okay, finally, 405, that's 81 times 5, okay? And I'll show you why. 81 times 5, 540, okay? So you go through your roots, and again, if you have a calculator, because the calculator is not going to be able to show you that breakdown, you could try, hey, divide it by 4. Does it go in evenly? If you get a whole number, you're good, right? If you don't, you keep going, right? Does 16 go in? Actually, another way you'd go in is actually, you could probably do, 9 will go into 405, right? Because if 81 goes in, 9 will go in. So 9 will go into 405, and 9 will go in, 9 times 30, 9 goes into 36 4 times, and then 40, yep. So you could do 9 times 45. Again, it's going to take you multiple steps, but there's multiple ways to break it down. In any case, in the end, you get to 9 times the square root of 5. Okay, I like fives. I'm a big fan of fives. All right, so that's how those ones break down. So just to summarize it up real quick. So in this video, the purpose was to be able to simplify square roots, not just the ones where they're whole numbers. So ones like 8 and 12. We took a look at these perfect squares, which are the crux of how you're going to be able to break these down. There's those essential pieces to the puzzle, right? We talked about how what we're going to do is we're going to use this multiplication property. The fact that if we have two numbers that multiply to the number on the inside, we can take the square root of the inside and break it down as the square root of that first number times the square root of the second number. Okay, and we use that as a foundation for this process. We break it into the two factors. Remember the factors because they multiply evenly to give that number, right? We take one of the numbers and bring it outside of the square root by taking the square root, right? Because we want to look for a perfect square factor. We leave the other number inside the root, and we just continue the process until whatever is under the square root can no longer be broken down, right? And we looked at numbers like 8 that were a little bit more straightforward, 50 that required a little bit more thinking, and then numbers like 48, 200, 320, and 405 that really required us to dig deep. Remember that there could be multiple different paths to a solution, but the goal is to simplify completely, to keep going until you cannot break them down anymore. Folks, thanks for taking the time to watch this video. I really appreciate it. Keep working at it, folks. This is not easy stuff, but just keep a positive attitude. And remember, you can do it. All right, folks, thanks again for watching. Don't forget to like and subscribe so you can be aware when my newest content comes out. And have a wonderful